Here's FRQ 5 of the 2025 AP Calculus BC exam. Part A asks, find f double prime of 1, the value of the second derivative at the point 1, negative 1. So to do this, we'll start with the first derivative. What we'll do from here is we're going to differentiate both sides with respect to x. On the left, first derivative just differentiates the second derivative, but on the right, we have two functions multiplied together. So we're going to use the product rule. So we have first times the second, don't forget the chain rule, plus second times the first. This is the expression for our second derivative, and now we just need to plug in 1, negative 1. We find that dy dx at 1, negative 1 is 2. The second derivative at 1, negative 1 is negative 9. Part B, we have to write the second degree Taylor polynomial for f about x equals 1. A second degree Taylor polynomial centered at 1 will have the form f of 1 plus f prime of 1 over 1 factorial times x minus 1 to the 1 plus f double prime of 1 over 2 factorial times x minus 1 squared. And now we just fill in the blank. We know f of 1 is negative 1 plus f prime of 1, as we found, is 2. Divided by 1 factorial is still 2 times x minus 1 plus second derivative at 1 we found is negative 9 divided by 2 factorial. That's minus 9 over 2 times x minus 1 squared. In part C, they say that use the Lagrange error bound to show that this differs from f of 1.1 by at most 0.01. Remember the Lagrange error bound, which says that the error between the actual function and the nth degree Taylor polynomial is at most the next neglected term. So here we have the error between the actual function and the second degree Taylor polynomial is at most the third term. We know the maximum value of the third term is the maximum value of the third derivative in some input z from 1 to 1.1 divided by 3 factorial times x minus 1 cubed. So now all we have to do is compute this and show that this is less than or equal to 0.01. For the third term, we're told that the maximum value of the third derivative is 60. We divide that by 3 factorial and multiply that by, so we're trying to approximate 1.1. So it's 1.1 minus 1 cubed, which is 0.01, which goes back to show that this error is at most 0.01. Part D, they want us to use Euler's method starting at x equals 1 with two steps of equal size to approximate f of 1.4. So remember, this is the Euler's method formula, and they tell us that f of 1 equals negative 1. So that's our x0 and our y0. Now we need to choose our step size. So if we're going to go from 1 to 1.4 with two steps of equal size, the step size must be 0.2. So our x1 is 1 plus the step size, which is 0.2, which gives x1 is 1.2. And so x2 is 1.2 plus 0.2, which is 1.4. To find y1, we have our y0 plus the step size times the derivative at 1, negative 1. Part A, we find the derivative at 1, negative 1 to be 2, so we multiply by 2, which is 0.6. So with this, we can go ahead and find our y2, which is our y1, 0.6, plus the step size times the derivative evaluated at our x1, y1, so 1.2, 0.6. We find dy dx at 1.2, 0.6 is 0.648, which you use here, and I'm just going to leave this as an answer because this is crazy that they asked this on a no calculator section. No idea what college we're doing with this part D, but that's the 5th FRQ. If I made a mistake, be sure to let me know in the comments and check out the rest of my page for that last FRQ.